Okay, let's unpack this. We are diving into a network that promised, well, unprecedented, truly game-changing speed. They were claiming the ability to handle millions of transactions per second, TPS, only to hit the live market and immediately become known by this pretty damning moniker, the ghost chain.
Oh.
That's just a staggering disconnect, frankly, almost unbelievable for a project that had so much hype around it. Today's deep dive is tailored for you, the learner. We're focusing intensely on the Kita network, and our mission, it's critical, really precise. We need to understand the huge chasm between Kita's advertised, almost mythological performance claims and its actual highly scrutinized real-world output, the numbers. They just don't align, not even close. And we need to figure out why. So the core question we really have to resolve is this. Was this massive failure in adoption and activity just down to, fundamentally faulty artificial testing conditions that basically created a fake narrative? Or does the network simply lack the underlying architecture to deliver what it promised once it faced the friction of real economics, actual decentralization, and let's face it, market skepticism? To guide us through this complex synthesis of technical metrics, structural flaws, and what really looks like catastrophic community trust issues, we have our expert speaker ready to dissect the source material we've gathered.
It really is fascinating here how the entire narrative of staggering speed was so meticulously constructed, built entirely upon these highly controlled, basically centralized laboratory environments, and then how instantly that narrative just evaporated once it confronted the messy, complex realities of real-world decentralization, network latency, economic incentives, and crucially, market trust. I'm going to drill down into the hard data because the discrepancy between the claim and the reality here is maybe the widest we've seen in recent blockchain history. And it offers some profound lessons, I think, on how you should evaluate future scaling claims.
Okay, let's set the stage. That initial claim really captured the industry's imagination, didn't it? Keto wasn't just claiming, incremental improvements. They were positioning themselves as the definitive solution to the blockchain scalability trilemma. And that staggering performance claim, the absolute peak of their advertised capabilities, it came from that heavily publicized June 2025 stress test. The specific number thrown around was truly astronomical, 11.2 million transactions per second. And to give it absolute credibility, they publicly stated this was achieved in partnership with Google's Spanner engineering team.
Right.
This was meant to be the irrefutable proof, independently validated, the thing that redefined what was technically possible in this space. Now, if we use a practical analogy here, Kita essentially claimed they'd engineered and successfully tested, like a Hyperloop system capable of moving millions of passengers instantly.
Hmm.
But once the system went live, the infrastructure struggled to power, I don't know, a small electric scooter. The gap is just profound.
That analogy is actually highly appropriate because we have to move immediately from that peak theoretical number to the actual observed performance. The performance that instantly contradicted everything Kita had advertised. This is where the uncontrolled metrics, the data seen by third parties, tell the real story. So we need to analyze the testnet reality check. This happened immediately following that June publicity blitz. Performance observed outside of that highly controlled stress test environment. It was orders of magnitude slower. We have specific data points monitored by independent third parties like ChainSpect. They revealed the actual TPS on the testnet wasn't even breaking 5 figures. It was fluctuating wildly, settling somewhere between a low of 12,210 and a high of 1,779 transactions per second.
Wow. Okay, let's pause on those numbers for a second because the sheer scale of the failure here is critical for you, the learner, to grasp. If the peak claim was 11.2 million and the observable reality was hovering around, what, 1,500? How massive is that discrepancy?
When you calculate it, the scale of this failure, the numbers are genuinely shocking. That observed performance is nearly 7,400 times lower than the claimed peak performance of 11.2 million TPS. I mean, imagine the difference between using a top-tier supercomputer for climate modeling and maybe a cheap pocket calculator from the 90s. That's the order of magnitude difference we're talking about.
Yeah,
Even under what you'd consider normal testnet conditions, the observed TPS consistently stayed below 5,000. This disparity is not a rounding error. It indicates a fundamental structural difference between their theoretical lab setup and their actual operational capacity.
And Kita obviously felt they had to offer an official explanation for this, well, abysmal performance gap. But when we dissect that rationale, it actually shines a huge spotlight on the precise structural flaw you mentioned earlier. What was their reasoning for that low testnet TPS, the 1,200 to 1,700 range?
Okay, so Kita's official rationale, which they publicized quite widely, was that the network intentionally does not support unlimited scale expansion because there is no transaction fee. Their core argument was economic.
Yeah.
Basically, without fees, they had to intentionally throttle throughput to prevent denial of service abuse, spam attacks, things that would clog the ledger.
Okay.
They argued this was a responsible security measure,
Huh.
and they promised a special benchmarking network would be set up later for future testing to prove the high scale eventually.
But hang on a minute. That answer, it doesn't really pass the sniff test, does it? If the underlying architecture of the network is truly sound, if it's genuinely capable of processing 11 million transactions per second, then simply adding a standard economic constraint, a transaction fee, it shouldn't fundamentally slash the network throughput from 11 million down to 1,700.
Exactly.
If anything, fees should incentivize rational use and, preserve the network's capacity, not destroy it.
Precisely. This explanation actually reveals a fundamental design problem. While, yes, the technical validity of fee constraints is real, every blockchain needs economic limits to prevent spam. It implicitly tells us that the network cannot achieve 10 million TPS in any economically functional state.
Sure.
The moment you remove that fee constraint, their system seems to require self-throttling just to survive.
Right.
If a proper fee market were implemented, yeah, it would likely stabilize transaction activity, manage spam, but it wouldn't magically give the network back the 7,400 times performance it lost. The only logical conclusion is that the theoretical speed just evaporates the moment you introduce the complexities of a functional decentralized economy.
Okay, here's where it gets really interesting. And this is crucial for answering that learner question about why the test failed. We need to understand the, let's call it, technical manipulation involved. How did they manage to hit 11.2 million TPS back in June 2025? And why do those specific laboratory-level conditions just not reflect a functional, real-world blockchain environment at all? This section is really a deep dive into the artificiality of that test. The sources we have confirm that Kita's June stress test, while, technically impressive on paper, operated under these highly controlled and truly unrealistic conditions. Conditions that basically rendered the metrics useless for assessing actual capacity. This wasn't really a blockchain stress test, it was more like a database benchmark.
Let's break down the specific limitations then. The things that made the test invalid for real-world metrics. The first major flaw was the synthetic load generation. The test did not rely on organic user demand at all. No transactions generated by real people or entities wanting to move value or run smart contracts. Instead, the test used what Google's own documentation calls a fan-out approach. It's a technique where funds are artificially distributed in this very specific, hierarchical engineered pattern, designed specifically to generate massive, consistent, high-volume transaction activity. And this involved using transactions generated from over 30 million artificially created accounts. This is critical to understand.
30 million, wow.
Yeah. Organic demand in a real decentralized network is messy, it's unpredictable, it involves latency. Synthetic demand like this is clean, it's uniform, and it's designed purely to maximize sequential database rights. They were essentially simulating the absolute perfect condition, which basically never occurs in the real world.
So if the transactions were all predictable, coming from these fake accounts, they were essentially testing a pipeline with perfectly filtered, uniform water flow, rather than the chaotic, turbulent demand you'd see in a real city's water system.
Exactly. And the second, equally fatal flaw concerns minimal decentralization. This really hits the core principle of Web3 that the test completely ignored. When we look at the node count during the test, a crucial factor, that 11.2 million TPS, was achieved using only 4 representative nodes.
Just 4 nodes. Let's compare that for a second. Established layer 1s, they have hundreds, sometimes thousands of independent validators spread across the globe. Why does this 4-node setup make that 11.2 million TPS claim essentially irrelevant to actual blockchain technology?
Because 4 nodes is not decentralization. It's a controlled lab cluster. Simple as that. In a truly decentralized system, every single transaction has to achieve global consensus among potentially thousands of independent, geographically dispersed, and importantly, heterogeneously equipped validators. People running different hardware, different network connections.
Right.
That whole process introduces massive network latency, constant security checks, and significant computational overhead, just related to achieving and confirming consensus. A typical blockchain spends a huge amount of its effort and time coordinating these consensus checks. By limiting the test to just 4 nodes, Kita effectively bypassed the single most critical challenge of achieving high TPS in a genuinely decentralized system. They tested high-speed data writes between 4 known trusted points, not the incredibly complex challenge of securing a permissionless global ledger.
Which brings us directly to this question of cloud dependency. I mean, achieving 11.2 million TPS is an extraordinary engineering feat, no doubt. But if you have to rely entirely on the infrastructure of a single, highly centralized tech giant like Google to do it, doesn't that fundamentally negate the entire purpose of building a public, permissionless blockchain in the first place?
It absolutely does. And this is where the sort of proprietary risk really emerges. The performance was achieved entirely using Google Cloud's proprietary Spanner database, running across 4 geographically isolated regions, but all within the Google Cloud network. Now, Spanner is optimized for global transactional consistency and high throughput. It is, by design, an incredibly fast, highly centralized, enterprise-grade solution. So this massive dependency raises a deeply critical question for you, the listener. Is Kita a truly decentralized network architecture? Or is it fundamentally just a very fast, centrally managed cloud database that's kind of masquerading as a public blockchain? If the performance of your blockchain is intrinsically linked to the architecture, the proprietary software, and the guaranteed uptime of a single cloud provider's relational database, well, then you've simply outsourced your core centralization risk. Plus, you face huge risks of vendor lock-in. What if Google decides to change its terms or its pricing? What if the underlying Spanner architecture is proprietary and not open source? The network's entire foundation rests on a single point of technical and corporate failure.
So, okay, the test was flawed because it tested centralized database speed, which, let's be honest, is a largely solved problem in engineering. And then they marketed that speed as decentralized blockchain capacity, which is an entirely different, much harder, and largely unsolved problem. It really seems like the speed claims were basically a PR exercise, designed to attract capital, maybe developers, but completely disconnected from the engineering reality of building a trustless ledger.
That is the core finding, yes. The June test confirmed that if you use the best available centralized, proprietary, cloud-based database cluster, which Spanner arguably is, and you feed it perfectly synthetic data across just 4 nodes, yes, you can achieve very high numbers. But the moment they moved away from that highly efficient centralized infrastructure into anything resembling a truly distributed environment, or the moment they attempted to simulate a real economic model with fees and unpredictable user behavior, the claimed speeds were simply unattainable, resulting in that massive performance crash we already talked about.
All right, now we transition from the, let's call it, test phase fantasy to the live launch reality. The mainnet launched on September 22, 2025. So the core question for you listening is, what happened when those speed claims finally met the actual market? The answer is, well, it's striking mostly due to the sheer lack of activity. We have detailed data showing the stagnation right from the mainnet launch. Over approximately 49 days post-launch, that's nearly 2 months, the entire network processed only 753,000 total transactions. To put that into perspective for you, certain established blockchains process that kind of volume in a busy hour, sometimes even minutes.
Yeah, and when you average out that volume, you get approximately 15,400 transactions per day. Compare that to the claim capacity of 11.2 million per second. It's a historical failure in market adoption.
Absolutely.
The stagnation was so severe that, according to community reports and independent observers tracking the chain, the network frequently experienced hours, sometimes prolonged periods, with literally zero activity, nothing happening. This is precisely how it earned that damaging but ultimately accurate epithet ghost chain among observers. It launched claiming to be the fastest blockchain in the world, but almost immediately became one of the most dormant.
That's just devastating for any project, isn't it? But particularly one that based its entire value proposition, its whole reason for being, on speed. Now, this brings up that query from our learner. If the performance was so embarrassing right out of the gate, did the team go back to the drawing board? Has there been any other large-scale stress testing publicly announced after the mainnet launch? Did they try to prove the speed again?
That's an excellent point to clarify for everyone. The available data, everything we've seen, focuses entirely on the stagnation, that low transaction volume after September 22, 2025. There has been no subsequent publicly acknowledged pivot back to highly publicized, large-scale stress testing similar to that June event. The focus shifted immediately, away from trying to prove theoretical speed and towards managing the clear structural failure reflected by the total absence of users and dApps. This really suggests they recognize the immediate and glaring issues of utility and adoption were the far more pressing concerns. More pressing than rerunning another artificial speed demonstration that nobody believed anymore anyway.
So the problem stopped being, can we go fast? And immediately became, why is nobody even trying to get on our super fast highway? Let's look at one major reason for that lack of users, the user friction inherent in their design choices.
Absolutely. The stagnation isn't just about those centralization optics we discussed or the broken trust. It's also about high user friction baked right into the system from day one. KEDA introduced a massive barrier to entry for users. They required mandatory Know Your Customer (KYC) integration just to function on the network. And this was implemented using something called X.509 certificates. We would probably need to understand the technical and, maybe more importantly, the cultural implication of X.509 certificates here. These are digital certificates used primarily in highly regulated enterprise environments, think banks, corporations, to establish identity securely.
Right, I've heard of those in corporate IT.
Exactly. So to implement X.509 in this context means the network relies on a centralized certificate authority, some trusted entity, to verify and issue these digital identities. And this is pretty much anathema to the crypto-native audience, the core DeFi users, the builders. They're fundamentally trading away anonymity and permissionless access for regulatory compliance.
Okay, let me play devil's advocate for a moment. If KEDA's explicit goal was always to attract large-scale institutional finance, maybe this mandatory KYC was a necessary hurdle. Are we perhaps judging them too harshly based on the expectations of the typical, decentralized finance DeFi crowd who value anonymity above all?
That's a fair challenge, definitely. They were clearly targeting institutional adoption, traditional finance use cases that absolutely require strict regulatory compliance. And for that market, KYC is non-negotiable. It's a prerequisite. However, by imposing this right at the start, they effectively alienated the entire early adopter community. The crypto-native developers, the liquidity providers, the degens, the very people who typically build the initial ecosystem on a new chain. And crucially, they ended up stuck in this kind of no man's land. The KYC creates immense friction that the Web3 community avoids like the plague. So they repelled the necessary early builders and users. But simultaneously, the institutional adoption that was necessary to justify this friction, the massive banks, the regulated entities they were supposedly courting, it simply hasn't materialized, at least not yet, and certainly not at launch. So the mandatory X.509 KYC setup resulted in a system that, frankly, appealed to almost no one, resulting in the empty chain.
Okay, let's look beyond the technical specifications now, and even beyond the user friction. The primary reason for this mainnet stagnation wasn't just technical failure or economic miscalculation. It seems like it was a total sustained absence of community trust and, maybe more importantly, real utility. The foundation was already cracked, wasn't it, before the building was even finished? We need to detail the sustained trust damage that actually began before the network was fully live. Our sources point to severe fraud allegations that crippled confidence back in June 2025. Right at the time, they were shouting about their 11.2 million TPS. Michael Ruzic, the founder of DeFi Capital Markets, published these really detailed accusations. He claimed the KEDA Testnet Explorer was displaying fabricated transaction data. He wasn't just saying that the speeds were theoretical. He was claiming the data shown on the dashboard itself was fake, presented on what he described as a hastily constructed Vercel webpage. Vercel is a platform often used for rapid web deployment, sometimes for demos. His implication was clear. It was a sophisticated, deliberate attempt to artificially represent network activity where there actually was none.
Yeah, the credibility hit from that was immediate and catastrophic. And we need to differentiate here between KEDA's technical defense and the potential ethical failure. KEDA disputed the claims. Their argument was that cryptographic verification prevents the faking of actual signed transactions on the ledger. And technically, yes, they are correct about that. You can't just fake a cryptographically signed transaction on a blockchain.
Right.
However, Ruzic's point wasn't really about the cryptography itself. It was about the presentation, the user interface. They were accused of fabricating the dashboard, the thing that users see, the layer that shows activity making it look like the testnet was alive and busy when allegedly it was dormant. And that's a failure of transparency and honesty, not necessarily a security failure of the underlying ledger itself.
I see the distinction.
But when a project gets caught, or even just credibly accused of manipulating its public-facing metrics, the damage to credibility, especially among a decentralized community that values transparency, maybe above all else, that damage becomes permanent, irreparable, often.
And adding weight to these concerns, the sources also highlight that the project's marketing strategy itself seemed, highly suspect to observers.
Indeed. The respected blockchain analyst, ZachXBT, added significant weight to these concerns. He highlighted the project's heavy reliance on sketchy key opinion leaders, or KOLs, for promotion, rather than relying on organic, grassroots developer adoption, which is usually seen as a healthier sign. Furthermore, the analyst pointed out concerning levels of centralized control over the token supply by these KOL individuals. which strongly suggests that the project was relying on an artificial promotional push, maybe prearranged token sales, rather than genuine bottom-up developer interest or real institutional demand. Once that trust is broken by allegations of fabrication, by highly centralized promotional tactics, the flow of genuine developers and users, it just stops completely.
So, okay, the trust was broken pretty early on, but what about the utility? Even if trust is damaged, if the network was technically flawless and useful, you might still expect some developers to build on it, right? Yet the mainnet launched into this complete void, which points squarely to the zero developer adoption issue.
Yes, the lack of an actual product or ecosystem is ultimately the fatal flaw here. It simply means there was zero demand for the claimed speed. Why do you need a highway capable of 10 million TPS if there are literally no cars on it and no destinations built along the route?
Good point.
Before the mainnet launch, community members reported searching for projects launching on Kita. And the results, absolutely nothing. This isn't just, a missed PR opportunity. It's really a proof of concept failure for the entire ecosystem play. Furthermore, there was this crucial omission that signaled the emptiness of the network. At the time of the mainnet launch, Kita's official website lacked an ecosystem page. That's a basic fundamental feature provided by virtually every serious Layer 1 blockchain project, regardless of how new or mature they are.
Wow.
That single omission basically signaled to everyone there's simply no ecosystem here to promote.
That is truly astonishing. It really suggests the technology was developed entirely in this theoretical vacuum, without any corresponding effort to build the community, the decentralized applications, the infrastructure that actually uses a blockchain. What specific products did they even promise on their roadmap that were missing when they launched?
The product roadmap was critically incomplete. And the absence of these core features really created that demand vacuum we talked about. As of October 2025, remember, this is after the main launch, crucial products needed for any kind of mainstream adoption were still listed just for future development. They hadn't even started building them, apparently. These products included Kita Pay, which was intended to be their non-custodial neobank service, the Kita Card, designed for integration with traditional payment systems like Apple and Google Pay, and the Kita DEX, their own decentralized exchange. These applications, they aren't optional accessories for a new chain. They are the core utility that would supposedly drive the high transaction volume they claim to support.
Exactly.
The absence of a native DX meant there was no liquidity, no place for users to trade assets on Kita. The absence of the pay and card products meant there was no practical bridge to the traditional financial world they claimed to target. You simply cannot launch a revolutionary high-speed highway if the essential destinations, the dApps, the services, haven't even started construction. Users had absolutely no compelling reason to bridge assets or interact with the network at all.
And just to compound the isolation, the network started with extremely limited asset support as well, correct?
That's correct. The mainnet began with only Base as a sort of structural anchor, and it supported only 4 core assets initially: their native token, KTA, USDC, URC, and CBBTC, likely a wrapped Bitcoin. This is a tiny fraction of what a viable Layer 1 ecosystem requires to get started. If a user can't easily transfer common assets like ETH or other major stablecoins onto the network, there's just no reason for them to participate, no way to interact meaningfully. So the combination of that early trust damage, the mandatory friction from the X.509 KYC requirement, zero ecosystem, and limited assets, it all resulted in the mainnet's total transaction volume stagnating below 1 million over nearly 2 months, cementing its status as the ghost chain. #outro.
So what does this all mean for you, the learner, trying to make sense of this? The verdict points overwhelmingly toward fundamental structural issues and a catastrophic failure of market adoption, rather than just, test limitations or minor launch bugs. Kita failed because the massive claims about speed were completely divorced from the practical realities of decentralization, market trust, basic utility, and user demand. That massive performance gap, that 7,400-fold difference between the claimed 11.2 million TPS and the actual observed 1,700 TPS, it was merely a dramatic symptom, a symptom of a much deeper crisis of credibility and utility. The network simply failed to deliver a compelling reason for anyone to actually use it, even if its theoretical centralized engine worked flawlessly under lab conditions.
Yeah, if we summarize the core reasons the Kita mainnet failed so quickly, so spectacularly, we can really identify 4 key structural weaknesses that led directly to that ghost chain verdict. First, those sustained testnet fraud allegations, particularly the alleged fabrication of the Explorer dashboard. That destroyed institutional and developer confidence before the project could even gain any real traction. Second, The network proved pretty conclusively it cannot deliver anything close to its claimed real-world performance while maintaining necessary economic incentives, like transaction fees. It demonstrated that stress tests run without fees are just not representative of a functional blockchain economy. Third, there was a complete total absence of a functional ecosystem, or any compelling decentralized applications like their own DX or pay services, which simply meant there was no actual demand for the network's supposed speed. And finally, those unresolved and deep centralization concerns, stemming from the heavy dependence on centralized cloud infrastructure, specifically Google Spanner, and that initial 4-node test setup. These continue to raise existential questions about the project's adherence to the core principles of Web3. And this whole failure prompts an essential, maybe provocative thought for you, the listener, to carry forward as you evaluate other projects.
Right.
Given this reliance we saw here on hyper-efficient centralized cloud solutions like Google Spanner to achieve these huge TPS claims, how far can a project push speed before it crosses a fundamental line? The line between being a decentralized permissionless blockchain and merely being a very fast, perhaps regulatory compliant, but ultimately public cloud database. And at what point does that reliance on highly centralized infrastructure negate the entire purpose of building on Web3 in the first place? That tension, that trade-off between speed and sovereignty, between performance and decentralization, that's the crucial lesson that the Kita story leaves behind.